Ooh.
Okay, that is recording. I don't know if you want to just use my computer and like go off of this,
Sure.
or if you want me to scroll through it, or
Well, I mean, I don't need to be on the screen. I just want to make sure people can hear me if that's the microphone.
can you all hear Gwen? Yeah, I think they can hear you. So if you just talk loud.
Okay. Good morning, everybody. It's great to see all of you. So I see Chloe, Jack, James, and Kinjal. Is there anyone else?
Oh yeah, we got.
Oh, wow. Okay. So we've got, hi, Annika. Hi, Becca. Is that
everyone?
Okay, awesome. Well, for many of you, I feel like you may have more that you could contribute from teaching this than from being the recipient, because I know from just having seen your research that you've done all of these steps. Kudos to Roz for having just organized and put all of this together. As you can see on the shared document here, there are a number of learning objectives that we're hoping to accomplish through this series of sessions. So I want to be clear that there's absolutely no way we're going to get through these 7 things in an hour. But first and foremost, especially to perhaps to the extent that our undergrad RAs or newer graduate students don't have experience in data cleaning, it's just an opportunity to talk about and outline the steps in the process, or part of, I think, what we're also hoping to accomplish is just having a very clear methodical process for how to go about data cleaning that, at least in my experience, should generalize across projects regardless of research question. And it's my hope that because we're a PhD program and you're all being trained to be independent researchers, that you not only go through the process in cleaning data, but that you really understand why we're taking each step and what the purpose is and what we're trying to accomplish, not just checking boxes for going through it. And then there are a variety of different data management and statistical tools that will be essential for being able to accomplish each of the steps that we describe. So beyond just knowing what the process is, it's our hope that you will learn and understand and know what those data management and statistical methods are that you can use for accomplishing this. And I've been doing this work for 27 years. And through those years, I've made my fair share of mistakes and things that I've learned the hard way, and then things where I've seen others trip and stumble in ways that ultimately took more time on projects than needed to happen. And so with regard to number 4, if you can learn from my mistakes, awesome. And if we can help you prevent making future mistakes so that your process goes smoothly and more quickly and hopefully more accurately, I think that's a great goal as well. And ultimately what we hope is that not only you have this knowledge, but then you can apply it to your own data or the other projects that you might be working on, so that then you can have data that are ready for doing whatever analyses you need and want to do so that you can answer your research questions. One of the things, so to the extent that in IO psychology and in occupational health, we rely a lot on survey research methods. One of the things that's come about in the literature, it's been there for a while, but it's a lot more attention has been focused on it for the last 15 years, is the notion of using attention checks as one indicator of data quality. Actually, now that I think about it, I think when I think about learning objective number 6, it's just identifying and understanding a variety of ways that we can evaluate the quality of the data, with attention checks being one specific method that we can use as a criterion for helping to, our goal is to help ensure that the data we have are legitimate and valid. And then to the extent that R is free and has quickly become a more popular method for doing analysis, one of the things we're hoping to do is establish a toolbox of R code that is then available for people that need examples. And thank you, Chloe, for putting Jason Huang's article and the Newman article in the drive, just as more information about those attention checks. So let me just pause and see if there are questions, and importantly, see if there's anything else you were hoping to get out of this before we continue.
Good girl.
Becca, your microphone's on, just so you know.
So sorry, my dog is crying at the moment.
Oh, poor sweet thing. So, and I mean, I've worked with some of you quite a bit in this capacity, and others I haven't worked on at all with empirical research. So for those of you who have worked with me, I think what you're likely to experience is just a revisiting what I hope that we've talked about, so that then it just solidifies some things. And I'll also say that you're getting kind of my paradigm and my view on all of this, and to the extent that others, like Jack, you've worked primarily with Tori, Annika, you've worked primarily with Josh. If there are other things that you've learned or ways in which you've approached this that are either different ways of doing it or other things that we don't mention, I just encourage you to speak up so that we can all learn from this process. Although it's maybe set up in this top-down manner, I really think of this as just a process, and all of us working through this together. So today we're hoping to just go over what the key steps are in the process, why it's important, and to note what the key decision points are that you need. Talk a little bit about the process for downloading or retrieving data and the steps involved in setting up your data set. And I will say that data management, which is the whole process of kind of getting your data together and ready for analysis, can be an incredibly tedious and time-consuming process. And there have been many times in my career when I've tried to take shortcuts and just jump in and analyze the data. And although I might get that initial, data run a little more quickly, I've usually kicked myself somewhere along the process. And I just can't say enough how having a well-organized, clear, and well-structured data set with all of the details can really pay dividends later. And one thing, and particularly if it's a project you work on and then you set it aside, like say you complete the project, you submit the paper for publication, you go about your merry way, and then 3 months later you get reviews back, and then you need to reanalyze data. And then if you have to refamiliarize yourself with everything because your data set is lacking those details, it can just be very costly in terms of time compared to if you set it up well to begin with. So in terms of steps, thank you. And please pipe it. We have the chat showing up on our screen here. So if you have questions as you're going, please don't hesitate to pipe into the chat. So we'll, in coming days, we'll talk about some of the data quality issues, like ways to look at attention checks. We'll talk about how to evaluate outliers and what to do, or what the options are for what to do when you have outliers. And then we'll talk about other things like checking assumptions for common statistical analyses, missing data, which we could easily have a whole course on that, and then psychometrics. And to the extent that at least all of you here, or just about all of you, I think everybody here has background in psychometrics and has taken measurement at the graduate level. I don't think we can nor want to repeat what Alyssa does well in an entire course, but we can certainly talk about psychometrics and just an overview of the steps and ways for approaching that as well. So starting with data, there are generally two ways in which you will acquire data. One is primary data collection, and the vast majority of us who are conducting surveys gather it using Qualtrics. And then the second way for getting data is from some other source. So they may be archival data. For example, James received a data set for use for his thesis that others collected. I work with a ton of larger data sets from other sources and so forth. The other data sources could even be things where you're hopping on a project where somebody else collected the data as primary data, and now you're just getting on the project. And so you don't personally have to download it from Qualtrics, but you're jumping in and using it. One of the things, so looking at, okay, so hold on, I'm gonna back to our objective. So just giving an overview of the steps, and then we'll come back and dive deeper. So one is just downloading and acquiring your data and things to know or be aware of. The next thing is saving your data set and going over just some very detailed logistics as well as some ethical issues regarding saving your data. Then we'll talk about ways to set up your data and ways to clean and organize it so that it can be more useful. And that's probably as far as we're going to get through today. But then we'll talk about data quality as well as attention checks. And then step 4 is really conducting a series of analyses to look descriptively at the data and begin looking at other data quality indicators. And then we'll talk a lot about missing data and how to, a big factor with missing data is one, just evaluating your data set and looking at your data at the person level, the item level, and the scale level. So the person level is when you might be missing respondents altogether. So you may have some non-response bias, or you at least want to evaluate whether you do, because some people will have completed the survey or data collection and others have not. Item level missing data come about when you have respondents in your data set, but those individuals leave items blank. So they skip items or may give you not useful data like don't know or refuse to answer questions. And then scale level is where you may have people who left enough items blank that you are not able to construct a valid scale score for somebody at the construct level. And so how you evaluate each of these things is a little bit different. And then we'll talk again through just decision points and what to do when you encounter these different things. And then the last part is computing and evaluating psychometrics so that you can help ensure that you have reliable and valid measures for being able to proceed with your data analysis and answering the research questions you have. So I think the part at which we will call our job done for this data cleaning workshop is when you have a complete clean data set ready to then go run the analyses that you've laid out in your analysis plan for answering your research questions. That's the part where we'll jump off and not get into here. So I'd like now to just pause, see what questions you have, and then we can go over some of these things in more detail. Let me also just ask, are there any steps that you were thinking of or that you recall having done in your own work that that we've forgotten about or neglected to mention? Nope. Okay. And I'll also just add that, you know, getting your data is a lot of work, but there are just a lot of time-consuming steps necessary to help ensure that you have a good, clean data set ready to analyze. And so the first part is just being mentally and logistically prepared for the fact that it's going to take some time to get your data ready. So in terms of downloading data from your source, the first recommendation is with it. So if you are within Qualtrics or SurveyMonkey or some other online survey platform, oftentimes there are ways for setting up the scoring in the background so that when you download your data, there are already appropriate values in there. And to the extent that you can set that up a priori within Qualtrics will likely save you time later. And just an example from experience there is a former grad student had conducted some research in Qualtrics, downloaded their data, and went off and running and computed their statistics. And much later on in the process, found that in the background of a Likert type response scale from strongly disagree to strongly agree, where I think a norm is that we scale that we set those up and code those as 1 through 5. In this particular case, the values were bouncing all over the place, and it was still within the right range, but they, for some reason, weren't in numerical order. I think because sometimes in Qualtrics, when you increase and then decrease the number of items in your scale. So for example, if you set it up as a 7-item scale and then you back it out to 5, or you go from 5 to 7, in the process of moving back and forth, unless you double check and assign values in the background, you can end up with things that just don't make sense. And in this particular case, the analyst had data that were not just on a 1 to 5 scale. And then when they computed all the means and ran all of their stats and put all of the tables together, and then later found this error, they had to go back and fix everything. And that issue could have been prevented by just double checking all of this stuff at this stage. So if anyone, is there anyone that has questions within Qualtrics about how to set this up? It's usually an option on the left side for setting up scoring. Right, so is it helpful to see it, or does everyone know how to do it? Or is it, if this is being recorded, is
It is being recorded.
this
so.
the kind of thing that for others that it could be that everybody here knows how to do this? Sure. Okay, so we're just going to show a quick example. The other thing is also having done this and having worked with Qualtrics for a very long time, periodically they update software, and just when you know how to do this, they change the layout.
So we want to look at.
So it's looking at the scoring.
Good values usually what I go to.
Okay, yep, so that's, yep, exactly. So if you saw what Roz just did, it's scrolling down within a particular question and then making sure that the values that are there for recoding make sense. One thing that sometimes happens in surveys is that we use items that are negatively worded. My recommendation is that you not do that kind of recoding within Qualtrics, but that you just have a consistent setting of 1 to 5 or whatever you're using, and then have good documentation later about the negatively worded items. Otherwise, it may be harder to remember which ones were negatively worded. And one issue that I had with my dissertation data, which I analyzed via SPSS, is that I had recode syntax and I recoded into the same variables. And if you run that twice, you end up like wiping out the recoding that you've done. And so the more you can just have clear steps in which you have good documentation for what you did and how you did it, the better. So starting out with that recoding in the background and then downloading your data and then using code going forward as documentation is helpful. Another thing is sometimes there are survey questions where there are legitimate don't know or refuse options, where rather than having somebody answer a question here where it's just never through always, but you may have something where if somebody doesn't know the answer, you don't want them to just throw a value in, that having a code for that is helpful. I usually like to use things like an 8 for don't know and a 9 for refuse, because if you just have it as a 6 or a 7, it can become harder to remember when you're looking at the data that it's not a 6 or a 7 point scale.
Is there a reason why you don't do 0, or does it not?
That's a good question. You I think part of my use for 8 or 9 is just based on some of the huge archival data sets I've worked with, where that has just been the standard that if you ultimately you'll want to make a decision of whether to call those people missing or what to do with it. I just find that when it's a value that is not closely tied numerically to the rest of the items in the scale, it helps. The other is a norm that I've used is when it comes to yes/no scales, using a 1-0, so that then when you calculate the mean of, well, don't get me started on means of categorical variables, but that a simple yes/no 1-0 to me is just intuitive and easy to see with the data. And then if you have a 0, then you can later confuse what that 0 means. So in stuff that I do, I end up coding dichotomous things using 0. And then if I'm using 0 for a don't know or refuse, there might just be confusion. So just in my own brain, I try to do things kind of consistently across projects. But I mean, one thing is that I worked at the University of Michigan for 12 years, where 85% of my job was data management for the first 5 or 6 years. And there were just things that I just learned and did, and partly for consistency with others. And so I guess that's why you're getting this.
So Chloe asked about talking about the pros
Yep.
and cons of an NA option.
Sure. So that's a really great question, Chloe. I'm happy to answer that, but I want to keep this focused more on the data cleaning rather than the survey design standpoint, only because I'm worried that I could easily jump down a rabbit hole of the measurement side and the survey methods, rather than focused on what we need to do once we have the data. Does that make sense? Is that okay? I'm happy to circle back to that.
Yeah, she suggested we put it in the document for later. So
Yep.
I'll make a note of that.
Yep. And then Becca's right that sometimes I've used 99 or 999 for missing values, and I particularly have done that when using M+. Just because it's easier to call them out, and that's, I guess, just because that's how I was taught. So again, this is where I really, if others of you have learned other things that have worked, by all means speak up. You're definitely getting my take on how I've done this and what I've done, but by no means is that the only way or the right way. Yeah, so Chloe, that's so yes, analytically that is that's definitely, so Chloe said that there have been some power issues when using a not applicable option when it's a variable in the primary model. I think that, again, that's just, I think, a measurement issue of what is it that you're measuring, and you can definitely run into some power issues. But if truly what you're asking and how you're asking it, if the appropriate response is that it doesn't apply to them, yeah, so it definitely gets tricky, and I'm very happy to chat about that. I think in your particular case, Chloe, I think there may be other ways of asking the questions to help minimize the risk of losing valuable missing data. Yeah, okay, thank you, Julia. So Julia indicates that she also uses the -999. And that may go even back to your thesis when we worked on that. Okay, so when you're downloading data from Qualtrics, you're given a choice of how to download the data, and one option with the CSV file is whether to use choice text versus numeric. If you download it with choice text and you have scales such as a Likert type response scale with strongly disagree to strongly agree, it'll pull in the strongly disagree, those kind of values instead of the numeric code. And that you can handle that, but in my experience, it just creates an extra step in the process compared to if you assign and recode the values like Raj showed you how to do, and then you download the data, and then you have those numeric codes. It's interesting. I was chatting with Alyssa about this recently. Alyssa prefers to manage the data with choice text and then do the recoding. And I guess one advantage of doing that is then your raw data show the response scale and what the text options were at the time you collected it. When you download it as numeric, you are relying upon the fact that the coding values in the background are accurate and that you can make sense. So when it says a 4, that you know what that 4 is. So I think Roz and I prefer to use the numeric stuff because it saves steps, and I think it's less work when Qualtrics does this coding for you, but it's really critical that you review your Qualtrics survey carefully to make sure that it's accurate, and double checking it is highly recommended. So any questions on downloading data from Qualtrics and what to do there? Yep, absolutely. Having a code book is absolutely essential.
I have a note on that. So in Qualtrics, you can also download your like survey, and that's what I tend to do. And you can download it too, so that it shows you like the numbers that you've assigned everything. So I downloaded, I printed out, and then I can see like, you know, are the numbers how they're supposed to be. And then if I code other things, I can always like go back and edit either the Word document or on my paper. And that's been pretty easy to do.
Yep. And thanks, Roz. And I agree with that. I think for relatively small scale stuff and where you're doing it primarily yourself, that process can work really well. Where the actually going the extra step to put it in an electronic code book and documenting more of it is helpful is when you're sharing it with multiple people. And particularly just if, yes, and I've had really positive experiences with undergrad RAs that have helped put code books together. I think it's a really good experience. It's where it's one way to get some of our students with less statistical experience some exposure to data. And I have some examples of code books as well as what has worked well and not so well that I'm happy to share. And one of my favorite examples is one that Lisa Kath has used with her hospital studies, because we put those together, and I've since used that as a model. So with regard to archival data, it's really essential that not only do you get the data, but that you also get all of the documentation, including codebooks and questionnaires, because without that additional metadata or documentation, it's really impossible to understand what the data are that are in those data sets. And studies vary tremendously with regard to how user-friendly those documents and codebooks are. And in my experience, the variable names and variable naming conventions can be flat out horrible. And it can be quite a lot of work and very, very time consuming to comb through codebooks and questionnaires. Roz and Chloe will circle back to the project talent data, but I think that's a perfect example of just, you know, you find, okay, this question is Q13 and there's nothing that tells you what Q13 is other than knowing that that's the question in the questionnaire. And then the next wave, they may have the exact same question, but that time it might be Q42 instead of Q13. And so in those cases, I've spent copious amounts of time putting what's called a concordance database together, where when you're linking data across waves and you want to keep track of consistent questions and items, that you have a way of making those comparisons, and then also noting when wording in questions has changed, because that can be important when trying to look across various time points and so forth. And it would be very easy to dive down into a rabbit hole of what to do. I think a lot of that stuff is best on a case-by-case basis, depending on the data set. But if anyone just wants some experience looking at data documentation, codebooks, and questionnaires with some complex data, I have plenty of examples to share. With regard to archival data, the sooner you can identify which variables you want in your data set, that can be helpful. And depending on the size of the data set, you may want to then parse out the specific variables that you're interested in for your study. Some of the projects that I work on literally have thousands of variables across 20 waves. And so when you have data sets that big, they can just be very, very cumbersome to work with. And I find that I just go in, get the variables that I want and need, save them in a new data set, and then I'll work with, clean, and manipulate the stuff that I'm working with. And I can always go back and merge in things later. And exactly what you do to set that file up and what software you use will really depend upon your resources and what works. Does anyone know how well R works for merging across different data files? So for example, if you have the same participants across multiple waves, is it fairly easy to merge across those in R?
Josh gave me resources on that, and I'm about to do that soon, but I have not done it. So I can provide resources on how to do it, and eventually, in the next few weeks, that will be.
Okay. Awesome. All of the work that I did at Michigan used SAS. I began with SPSS, and I quickly found out that SPSS is, at least at the time, 20 years ago, did not have the capability to handle large data sets, and it was really slow. And everybody I worked with from sociology and other fields used SAS. And so if I ran into trouble, because I use SAS, it was easier to get help and support from others. And there were a lot of resources about how to use it. And this was before, if R existed, we certainly didn't know about it. So R was not an option for us then. And I've personally just stuck with SAS because I know it. But I think to the extent that all of you are learning R and can then acquire skills for doing this in R, that's helpful, especially because SAS is pretty expensive. Brittany?
So my question concerns if folks were to want to see our analyses or reproduce our analyses or whatever that looks like. It seems like Josh has a tendency to want us to do a lot of the data cleaning and data wrangling steps in R versus Excel, even though I'm more confident with Excel. Do you have any guidance related to or thoughts on that?
Yes, I have huge thoughts and very strong opinions. The biggest problem, I have a visceral reaction in which all the hair on my body is standing up right now as soon as you mention data cleaning in Excel, mainly because my recommendation, and I apologize if I sound like I'm being harsh and rigid, but my view is that everything you do with regard to data cleaning should be something that you could easily replicate. Let's say that you haven't backed up your data, you drop your laptop and your hard drive is fried. The good news is if it's archival data, you can get it from somewhere. If it's in Qualtrics, you just re-download it. But if you take steps in Excel for cleaning and you don't have code for taking those steps and you have to redo it, you can easily then double the amount of time. Whereas when you do it in whatever other program, whether it's R or SAS or SPSS, when you have syntax or code for writing out those changes, then you can just very easily apply it or replicate it. Although there are formulaic ways to do this in Excel, where it's maybe less manual as it might be, I haven't found or seen a good way where it's easy to follow the steps to see what's been done and how to replicate it. So, and I think my own opinion is that in Excel, it's possible to make an error that could be harder to catch because things are buried within cells and buried in formulas. And if you just simply click on the wrong cell or use the wrong function in what you're doing, it's not necessarily going to be as readily apparent, and it's harder to find and identify where those mistakes are made. So it's about replication and ability to error check so that ultimately you have accuracy. And just when you think I'll never need to go back and re-download my data and restart, I will just tell you that I've had to do that multiple times. And where I learned this the hard way was with my dissertation, when I accidentally recoded things that I had already recoded. And then I got to a point where I couldn't remember what was recoded or not. And so I just went back to my online survey software and re-downloaded the data and started over, and having all that code written out made sense. And then in that code, having very clear details about what are the steps you're taking and why are you doing that. And I've learned the hard way that that's helpful, not only with your setting up your data, but also with analysis. I once worked on a research paper, and it's a paper that's been published, and it's to this day been cited over 2,000 times, and it's prevalence data on dementia. So getting those numbers accurate was of the utmost importance. And I probably computed 250 tables before we identified exactly which tables we wanted for the final version of the table, for the final version of the paper. And my code just had all this code for these 250 tables. And then when we got the R&R, and I had to go back and check some things and replicate, I didn't have clear documentation about which of those 250 tables created the final version. And so just, again, clearly labeling your code and just saying like final version can, just the simplest comments in your code can save you hours and hours later. Did I answer your question about Excel? Does anyone have, I mean, I'm open to opinions if you disagree. Okay, so Julia said there's a way to use VBA script in Excel. Okay, I guess that makes sense because there is coding behind all of those things.
Did Chloe say too about that she merged her thing?
Yeah, she actually, there's some code that she provided and it's in there if you want to take a look at it.
For merging surveys in R?
Yeah. for
Okay.
merging
Is it
surveys and-
on the-
Yeah, I can't remember which one it's in, but it's in one of the code in there.
Awesome. You're all amazing. This is great. I really want to believe that R has the capability and the tools for doing this. I just don't know it. So, and I know Kim Henry also works with a lot of large archival data sets and is really, really good at SAS. And some of you have taken stats with Kim. I don't know if she's had advice on that.
Nice. Jack's gonna put her hand out in the folder.
Awesome, thank you.
That'd be really helpful.
Okay, I would love to see that, because again, what you're getting is what I did and what I was taught, but there are multiple ways of doing this, and ultimately you should do what works for you. So I please, like, I don't want to sound like the data Nazi here. Okay, so saving your data set. When you download your raw data, my opinion and experience is that having your raw data and then just saving it as raw, untouched data and not writing over that is helpful, so that then if you ever have to go back and check something in the raw data, you have it readily available and handy. You might be thinking, well, I can just go back to Qualtrics and re-download it. Well, I also remember a time when CSU was giving up their Qualtrics license, and there was a period of time when we couldn't access our Qualtrics accounts. And some of us had to fight and lobby for keeping Qualtrics as the resource at the university. So to the extent that you in your possession on platforms, whether it's your own computer or a server that you can access, it's just good to have that rather than assuming that it's in the cloud on a CSU server that you may not be able to access at some point. I also encourage you to have maybe an external hard drive or a way for backing up data that is not tied to your specific laptop or desktop computer. I know some of you have had some hardware malfunctions over time. And if you haven't, chances are we've all known of somebody who has. And so just backing up and replicating our data, it's just a good reminder to back up our files, because it's the minute that we forget or get lax in that you do what I do and spill a cup of tea all over your laptop and have to tell Donna that you just screwed some things up. So renaming, saving your data. My own preference is to put either original or raw in the data file name, so there is no question about what that is. And then I like to save data files with the date. Oftentimes I will do data cleaning or updates or do things. And sometimes I can be a data hoarder where I don't like to delete old files, but I'll update new files. And when I always put the date of the file, then there's no question to me which one is the most recent one, or if I know I need to go back a step, I know which one to go back to. So it was my quant colleague, Jack McArdle, that told me about his method where it's the data file name, then the 4 digits for the year, and then the month and the day. And then when you sort those by name, they will be sorted in chronological order rather than just relying on what your computer system says is like the most recent file date. So that's just my own personal naming convention. When you download that raw data, sometimes there are identifying information or pieces in those data sets. There are some legitimate cases where we have participants' names, email addresses, or things that are particularly identifying. And for ethical reasons, it's important to remove that kind of information that you don't need to keep sooner than later, so you aren't copying over and replicating and keeping multiple copies of things with identifying information. And there's a note here in the document of just remembering what you told the IRB you were going to do and then following through to do that. So if you say that you're going to remove all of these identifiers, remove all of the identifiers. I'm sorry, I keep turning to look at Rachel and Brittany in the room. I'm not trying to stare you two down. And so just being consistent about that. If you need to track participants over time, you can assign identifiers using characters that can then be sorted and merged based on participant identifiers. And usually I use character values for those, and I don't start with zeros because the leading zeros can get dropped depending on how those files get merged. So if there are questions about how to do that and how to merge files, happy to chat about that at some point. And my note here is the only time I recommend making a change directly to the original data file is when it is for ethical reasons to remove identifying information. I would rather you not say, but Gwen, you said save the raw data file and don't touch it. Well, ethics trumps that. Brittany? Excellent question. So for one, save your raw data files in as secure a place as possible. I highly recommend not saving them in Dropbox, Google Drive, or other cloud-like things. Google technically owns everything that is in Google Drive. Same thing with Dropbox. And so I think it is potentially dangerous when things are stored there. Here at CSU, the most secure place to store it is on one of our network servers. On my computer, it's labeled the T drive. You may have it mapped as a different letter, but it's where there are research folders. And Donna will create and give you access to a folder that you and only you or you and your advisor can access. In theory, whoever is on your IRB protocol, or at least the faculty member that was on there listed as the person in charge, should be able to access your data, simply because ultimately we're the ones responsible for what's happening there. Limit access to data to only those who really need access. Having, one other person, such as your advisor, have access is helpful, just with the whole hit by a bus phenomenon. I hope nothing happens to anybody, but also not losing data where something happens and someone can't access it is helpful. The servers at CSU are backed up on a regular basis. So it is less likely that if something were to happen, that those data would get lost compared to, say, your own personal laptop. If you are storing data on your own computer, it's useful if your computer is password protected in some way, shape, or form, and just trying to keep it out of cloud-based places. And I highly recommend not emailing data files, again, due to, well, two things. One, data security, and then two, sheer file size. It clogs up the email servers with large files. So there are file transfer protocols that can be used. What I've done when working with secure data files across institutions is putting them in a zip folder with password protection, and then communicating the passwords in some other mechanism via just like, not in that same protocol. Thanks. Hugs to you and your pup, Becca. And yes, we'll stay away from buses.
Do you know about the Microsoft 365 account?
Yes. That's still a cloud-based thing, and I would guess Microsoft owns that. So that wouldn't be my preference for where to store data. That said, we're in the middle of this faculty search, and I spent my night and morning reviewing applications. The actual applications are stored on the CSU application system, but all of our communication is within a secure folder within OneDrive. I think OneDrive through Microsoft is the next best option beyond on the hardware of the server. And one thing I can do is check with Donna about that. But generally my preference is to keep it on the T drive, and then get, just limit access. The downside can become access, because oftentimes you have to be logged in a particular way with dual authentication for being able to access those data. On the upside, I think that adds to the data security compared to, because sometimes stuff on the cloud in OneDrive, I don't know if it actually syncs to your computer or not, but there's just something about the actual technology that I'm less clear about with regard to data security, but we could pick Donna's brain about that. But please don't just email files back and forth unless they're small, inconsequential, totally anonymous kinds of things. Making a copy and backing up your data is just something I recommend. I've already said this, but to the extent that you can use code-based mechanisms for any deletions of participants, deletions of variables, renaming and changing values, just helps for replication should you have to go back and do it again later. Or for example, Roz is running a longitudinal study right now where some of the variables are the same at later waves. And to the extent that she already has code from the baseline wave, it's less work when you just copy that over, and you can just quickly do some word processing that, if your naming convention is that wave 1 is W1 and then your wave 2 is W2, it's just a very quick search and replace to just change those variable names for later waves, which is, again, if you are using other code-based mechanisms, it's just, or if you were doing it in Excel, it's harder to replicate. Any other questions about saving and storing data? We can move on to just step 3. So setting up your data set. The order in which you do these steps is up to you. I usually start with renaming my variables and naming them in a way that is fairly intuitive. I gave an example here that if you have a variable of job satisfaction, and let's say you have a 3-item scale, and you label it job sat 1, 2, and 3, then you can quickly see that, oh, that item measures job satisfaction, and you don't have to remember that Q13 is your job sat item. But it's really personal preference. It's, I think for a lot of statistical programs, starting with letters and ending with numbers works better than starting variable names with numbers. And there are some programs where it's still limited to 8 characters for a variable name, and anything beyond eight characters will be truncated. The other is that the longer your variable names, the more typing you have to do if you're writing code by hand. So keeping them short and sweet can just save you time.
Do this variable labeling in Qualtrics.
Yes.
Yeah.
Yes, absolutely.
Yeah.
So that's a good point. Is to the extent to the extent that you can't, anything you can do pretty easily in Qualtrics, I encourage you to do it because this will save you a step later. Some of this comes from my, unfortunately, multiple decades of experience with archival data that was not gathered via Qualtrics, and where all of the variables are nonsensical, like those Q13s. Like I will forever remember, you know, what HD 474 is in the HRS data set. Labeling your variables, is it absolutely necessary for your work? No, but it can save you time later, because let's say you want to know what the difference is between job sat 1, job sat 2, and job sat 3 without relying on your memory, and you can create fairly short labels to just keep track of what's what, because then depending on how you analyze your data, when you print tables or run, when you run analyses, you can create settings for printing the labels with those results, which can then save you time for interpreting the analyses without having to go back and manually do it, or copy it into Excel or copy it into something and then do a lot of copying and pasting. So I encourage descriptive labels, but not too long. I think putting the entire question wording in a label is too much, that you shouldn't need that much, and just be fairly brief. And then value labels, which again, you can do within Qualtrics, can help reduce ambiguity, so that when you have particularly categorical variables like male, female, or some race or ethnicity categories, you know what those values correspond to, particularly where there aren't consistent conventions. Strongly disagree to strongly agree, 1 through 5, that's straightforward. Yes, no, 1, 0, that's straightforward. But the number of times I've seen data sets where 1 is male and 2 is female, and then other data sets reverse those, it would be great if we just had some conventions. And so labeling within your data set can just add clarity, ultimately, to the extent that you have that information and don't have to keep referring back to code books to check basic things can be helpful.
Chloe, do you have R code for either of those things? Or does anyone have R code for that?
Or Chloe, did you do
Um,
that in Qualtrics?
Labels.
Which the labels?
Yeah.
No, I had labels in my code book. So I just did 1, 2, 3 for my scale items.
Okay. I know,
Um,
like, I know in SPSS, like you could see variable labels and value labels, but I didn't know if that you could really do that in R, I guess.
I mean,
Yeah, so-
you can, you'll just have a longer variable name.
Oh, okay.
Yeah.
I see.
Yeah, so I can also put up my like code book from onto the drive, if that helps.
Sure.
Julia, how have you done it?
For just naming variables,
Naming and labeling values.
I do it in SPSS, so you can like recode or not SPSS, in R, so you can rename variables in R. So if you download it, say with just like your JobSat 1, 2, 3, you can go back in and rename those something else that's more descriptive. You'll just have a longer like number for that. But then for recoding, I'm not sure if recoding values is what the code that you all are talking about, but I don't know a way to keep that row of description of what your item is without like ruining the integrity of your analysis, if that makes sense, because it still takes into consideration that row.
Right, right. That's where I think having the code book can be really helpful.
Yeah, definitely.
And again, to the extent that you can rely on Qualtrics where possible. But again, you may be getting data from somewhere other than Qualtrics. And so trying to cover all the bases here.
Yeah.
Well, we're out of time for the hour that we budgeted for today, but we did at least get through what we aimed to do today. Kudos to Roz. As long as we put the time estimates, as long as Roz does this, we're good. I apologize if I feel like I'm just doing a huge brain dump here, but I'm beyond passionate about this topic. I always wanted to develop like a 1 credit course on data management. I tried incorporating it the first time I taught a survey research methods course, but it just